and ANOVA the long way, or just the calculated way, in R. And in order to do that, first we're going to figure out all of the variables we need. So we're going to need the grand mean, we're going to need the distinct number of groups, we're going to need the total number of observations, we're going to need the group mean, and that's because we need the square of the different totals, so the body temperature, or yeah, the grand mean, we need the square of the different groups, we need the square of the different errors. Also, we can eventually, so this is going to be all of those in one group. Also, we can find our F statistic, which is the mean sum of squares between the groups over the mean sum of squares of the error, and then the p-value, which is just the F statistic, and then the degrees of freedom of the group and the degrees of freedom of the error. So we can find our F value and our P value to determine whether or not there's a distinct difference between the groups, okay? So, first thing we do is we pull up our data set, and then from that data set, as I said, we want to find our grand mean, and we're going to put that in its own little column over there. So, mutate, grand mean is equal to the mean of the body temperature, okay? And then we're going to find K, which is just distinct of the crab type. So we could find our distinct groups. And then N, which is total number of observations. And then from there, we need to find our group mean. So it's essentially the same thing as before. We're going to put that in its own column, and group mean is equal to, before we can do that, before we can find the group mean, we have to group by crab type, because we need to find the specific mean of each group from the group. So we group by crab type, then we add a column. I'll mutate group mean is equal to mean. Okay? And then from here, we're going to ungroup everything so that it does not mess up our calculations later. It's really important, okay? And then from here, we want to take all of this and we're going to find our sum of squares next. So now we add a new column, mutate. We're going to do the square of the difference of the total amount, which is equal to the body temperature minus the grand mean, and squared. Then we're going to find the square of the difference of groups, which is equal to the grand mean minus the group mean. Group mean? Yep. And then that's squared. And then we're going to find the square, the difference error, which is body temperature minus the group mean. And that is also squared. Okay, and from here, all of what we need, like we've done all the main calculations, so now let's summarize it. We can do that here. We want to show that our total is the sum of all of our where did I put it? Square different total, here it is. Our SS group is equal to the sum of I think it's square different groups. SS error, sum, square, different error. Okay. We also need to add our unique k, we need to find all of our unique groups, which is pretty much just k, but bear with me. N is equal to the unique observations, so no repeats. And our degrees of freedom of the group is equal to k minus 1, and our degrees of freedom of error is equal to our number of observations minus our number of groups. Total number is SS tot divided by number of observations minus 1. MS group is equal to the sum of squares of the group divided by the degrees freedom of the group. And then MS error is equal to SS error divided by our degrees of freedom of error. Okay, and then we want to get rid of our observations and our groups from this. Group. Oh, haha. One of these days I'll learn how to spell. Group by crab type. What do you mean? I grouped it. Okay. Figured it out. Woo! After that mishap, let's see what this looks like. Okay, looks like we got everything down. So now we can find our F statistic and our p-value. So let's take this and we're going to mutate it. Of course, this is MS group divided by MS error. Okay, and then our p-value is equal to by the distribution function, Q is F val degrees of freedom 1 is equals to the degrees of freedom of the group. Degrees of freedom 2 is equal to the degrees of freedom of error. And lower tail false. Okay. And now we just select for our FL and our p-value. And it looks like there is a significant difference between the groups. So the groups seem to actually be different. And now we can do that in R just with the functions that they use, that they have. So we're gonna create a linear model or a linear regression. So, and this is, you take the dependent variable by the independent. Okay. And then just type in ANOVA. And as you can see here, it's still significant, and we got literally the same answer. So you can do it either way. I highly recommend doing it this way, but if you do it this way, this will help you understand why this happens, I guess. And yeah, hope you enjoyed that. Good luck.